What up, YouTube? So we're back on the esk8 project. It's been a while. A couple of reasons for that. I've been kind of busy and I worked on other stuff that I didn't put on YouTube. And another reason is that since this is a fun project, I decided to source all the parts as cheap as possible. And you end up getting the parts from overseas, and there's a long lead times. But in this video, I'm going to start working on the remote control for the skateboard, and hopefully at the end of the video I'll have a functioning remote control. Now I'll go and switch to the overhead bench camera, and I'll start talking about my plans for the remote control. Okay, we're on the workbench camera, and I'm still experimenting with a new mic setup, new camera setup. But I kind of like this at a straight over view, and I don't feel like in the past I used to set the camera next to me and I felt like it was always in my way. I feel like I have an open workbench here. So yeah, so when it came to buying a remote, I was getting kind of picky about the style of the remote, and also I was trying to be cheap at the same time. So I'm just going to go ahead and say it. If I would have just went ahead and spent 50 bucks, I could have bought a pre-made remote that probably would have done everything I needed to do. But I didn't do that, and part of this project is just to have fun. So having to go out of my way to put this remote together, which is what I'm doing right now, doesn't really bother me too much. But I did make a big mistake, and the big mistake was buying this remote. Now, it's been like over a month, so I forget all the prices, but I will be posting the prices as the video goes on. And pretty much I saw this remote and I thought the form factor was perfect. It had a scroll wheel. I liked how it had the finger hole. It had the scroll wheel. And it had a lithium battery in it, rechargeable through USB on the bottom. And I figured that, this was exactly what I wanted. But I have, there was a big problem. And that big problem is, and I didn't realize this at the time, that this remote will only work on pre-made ESC setup that you get off of eBay. And it'll only pair to that. It's proprietary to that. And in the future, I did think about trying to see if I could get one of those ESC setups like extremely cheap, which I couldn't. And then if I got it, I was going to try to reverse engineer it to use this remote on anything. But that's a lot of work. But in the future, if someone did that, these remotes are like 12 bucks. And if you can figure out how to control them with anything, that would be the perfect fit. And I actually did buy this for like $1 or maybe $2, this receiver, because at first I thought all these 2.4 gigahertz remotes would, it was a standard protocol to the receiver, and I thought I could just buy any receiver and use a remote, but that turned out not to be true. But in the end, I want to try to get a remote that looks like this. So what I ended up doing was I bought this setup. This setup is for a remote control car. It has a throttle right here that you use with your trigger finger. And then it has a wheel for, it's supposed to be left and right. So it's 2-channel. It uses AA batteries. It's not rechargeable. And when I bought, and this came with a receiver. The receiver's over here. I'll plug that in a minute. But that's another lesson learned, is I thought even this would have a generic 2.4 gigahertz signal that would work on any receiver. And I found out that to be false too. I could only pair this with the receiver I bought. This receiver that I just FlySky, I literally paid under $2 for this. It's useless. You have to use, I guess, a FlySky remote. And so I've been messing around, and all these years since I never bought a power supply, I'm using this Arduino as a 5-volt supply. And here's the receiver, and I paired it to the to this transmitter, and I put a servo on it. So that servo is on, I don't know if you can see that. Servo is on channel 1, the steering wheel is on channel 1, and channel 2 is the thumb trigger. And I could use this the way it is. You know, it's not really that bad, but I want to have a thumb, use my thumb, and have it rechargeable too. Now the benefits of it not being rechargeable is if the batteries go dead and you're out in the field, you can just have 2 AA's with you and stick them in. But I don't think I'll ever use it that long, because hypothetically this battery should last longer than the battery in the esk8. But that might be what do you call it? Something I'll regret later. We'll see. So, okay, so here's the plan. Here's the new plan. The new plan is I'm going to take this one apart and try to arrange everything so it fits in a case like this with the thumb wheel. And I'm going to try to take the lithium battery out of this and the charging circuit out of this and put it in the new case that I'm going to 3D print. So my plan is to have one that looks like this, but it'll have the electronics using this remote. And since this one's 2 channels, and I'm going to have like peripherals on the control board for the esk8, I'm going to go and take one of the channels and make it 2 push buttons, so I can, you know, select different settings on the esk8. So I gotta pretty much take it apart, see how these work, and then come up with a plan of how I'm going to combine them all together into one remote controller. Now, before I do that, I just want to tell you I do have XBs, because a long time ago I bought XBs when the only way you could have wireless on your project was pretty much to use an XB. Now that's not the case anymore, but that's what used to be the case. And I did look into, what is it, Firefly remote, and I just didn't want to build that. And then I was looking into just making my own out of XB, but I didn't want to spend the time trying to come up with a protocol, you know, fail-safe protocol and all this stuff to, you know, make sure that the transmission's right. I just figured it'd be a lot easier just to use a already used setup. And I'm pretty sure that there's not that the electronics aren't that big in here that I can rearrange it to go in this style case. So we'll come back and see what I figure out. Okay, believe it or not, my plan is still the plan in my head. It might actually work. So this is what we got. Like I said, once I took them apart, there wasn't that much in either of them. This is in the one that I can't use, and the battery's mounted on the back. It's a 3.7 volt 20 milliampere hour battery. And then over here we have this one, which this is the size of the control board, really small. And what I did was, this is the potentiometer. Oh yeah, so everything was potentiometers. In this one here, they were using 5K potentiometers. In this one here, they were using an 8K potentiometer, but I took the potentiometer off of here. I unhooked one of the potentiometers from here, and I put in the thumb wheel potentiometer from this one, which is right here. And it works fine. As you can see, it controls the servo. So the plan is, I'm going to 3D print my own case. I'm going to use this potentiometer for the thumb wheel, since it already has a nice plastic piece. And this potentiometer was just press fit into these slots here. So I'm going to try to design my own case that uses these same slots here to hold this potentiometer. This second potentiometer I'm going to take out, and I'm going to put a resistor network in, and I'm going to have buttons that short out the resistors, and that way it'll change the signal, so you can have auxiliary control using those buttons. And I'm going to take this. I'm going to take this battery off, and I have these little modules left over. I believe I'll post on the video right now. You'll see what module this is. I forget off the top of my head, but this is a battery charging and a battery cutoff module for LiPo batteries. And I'll charge through the USB on this, have this as my battery source, and have this as my electronics. So now I just need to go and design a case that will put all this together. Okay, we are back. It's been, I don't know how long it's been, but I've been doing a lot of work in Fusion 360. Now, I'm not an expert at Fusion 360. I wish I was, because I know if I would have taken like a Fusion 360 class or what have you, that I would have been able to just go ahead and knock this out. I'm sure this project would have been real simple for someone who knew Fusion 360. But what I ended up doing was I took a picture of all the control boards and the cases, and I just kind of combined them together and traced them out, and I came up with this design right here. And this ended up being just a total waste of plastic, but I wanted to, once I created the design, I wanted to see how it looked in real life. So I printed this out, and I was like, I actually kind of enjoy this grip. I thought it came out pretty good. So from there, I went and let's see here. From there, I went and I tried to design it to fit the electronics, and I printed half of it, which is this half right here, and I realized that I really messed up on trying to design it. So I actually totally scrapped the project, with the exception of this layout here, this outline here. I totally scrapped it and started over. And when I started over, I came up with this design right here, which this design, I printed out both halves. It snaps together. And then the problem with this design is a lot of things didn't fit. None of the circuit boards fit. The spot for the potentiometer for the thumb wheel didn't fit. So I edited the file and edited the dimensions of everything. And here's the thing that I'm not good with Fusion 360. I know in Fusion 360 they have the timeline and you can go back on the timeline, but I don't know how to use that too well. So when I started editing it and trying to like make things bigger and what have you, it just got really convoluted. So, but I was able to print out a third design, or let's see, I guess it ended up being a fourth design. Ended up printing out a fourth design, and I was able to make the fourth design work, even though it's not perfect. And I'm gonna go ahead and press on, because I could sit here and keep on designing more, and I would never get the project done. So I'm gonna go ahead and press forward, and then maybe in the future, if I want, I'll try to create a better design. But I came up with this, which is this is the one I'm gonna use. And I did have to go and I did have to carve this out and what have you, carve something out here. Did have to carve it out, but it snaps together. The hardest part is the fact that the thumb wheel is held in by pressure only. There's no mounting points for the thumb wheel. So this works that it snaps together and it holds the thumb wheel in. Now the thing is, the seams, when it does snap together, the seams don't line up perfectly. Which I'll tell you, I went and I printed out a Raspberry Pi case that I got off of Thingiverse that snapped together, and man, that guy, it really makes you value people who can design real good, because whoever designed that Raspberry Pi case, I mean, it snapped together perfectly. But my seams aren't perfect here, but it snaps together enough to hold the thumb wheel and keep it together. And then what I did was, I have these two holes here, 3mm holes. I'm just gonna, and they're what is it, a dead hole? A dead bottom hole, which means it doesn't go all the way through. But what I'm going to do is once I get it together, I'm going to take a real small drill bit, drill in the middle there, and then reuse some of these black screws to just hold it together, and that's what's going to hold the two sides together. Okay, so now I'm going to go and try to assemble this. And the circuit boards and stuff are going to be held in with hot, they don't snap in or anything. You know, they're going to be held in with hot glue. This side's going to have the main wireless control board. Oh yeah, that's another thing. I tried to salvage the power switch from this control board, and I broke the power switch because they're really cheap switches. So off of Amazon for $5, I did buy a pack of these cheap switches to use. So pretty much I'm going to assemble this together. The transmitter control board goes on this side. The power switch is going to be in the bottom here, so I had to wire that in. And then there's going to be two push buttons that fit into these cells down here that's going to short out the resistor network for channel 2. And that's another thing I had to come up with, is the holes in it. The design works to fit the switch down in there, but you can't, you had to use like a pencil or something to press the hole. So I'm hoping that I can 3D print a small piece of plastic and just super glue it on the top of the button to make that work. And then on this side, the circuit board fits down in there for the battery charging, and you can get to the USB through the bottom there. And then the battery that's going to be salvaged off of this thing sits right on top of there. And then, like I said, then the thumb wheel just fits into this part here. Let me see. Oh yeah. The thumb wheel fits into this part here and just gets sandwiched in to hold it. And I tested it with it snapped together, and you can move the thumb wheel. Okay, so I'm going to assemble it and then we'll get back. Okay, so we're back, and I was able to make everything fit. Now, it's not perfect. I really messed up on the depth of everything, but I think I'm going to get it close enough that it's going to work, that I'm going to be able to put those screws in. But I thought I would just show it to you before I closed it up. As you can see, put the switch on the bottom, put the switch on the board here. Got the potentiometer going to channel 1. Channel 2 is coming down here to these resistor networks, which is 4 resistors, but 2 of these push buttons are in parallel with 2 of the resistors, and there's a center tap in between the 4 resistors, so that when you push the button, it changes the resistance, which then will change the signal, and that's how it'll do the push buttons. And I think I said the power switch. The battery actually fit perfectly with the charging circuit fit perfectly. That actually came out perfect. It's this side of the board that didn't come out good. But I'll do a little demo before I close it up. So let me turn on the power to the servo. Let me put the servo facing up here. Okay, so right now the servo is on channel 2. Okay, so we take the power switch, and then there's the power LED, so we turn the power on. Everything's connected. Now channel 2 is the push buttons, so I push the 1 push button. As you can see, as I push it, the signal changes. And then the other push button, it should go the opposite way. So that's how I'll be feeding that into the microcontroller, and that's how I'll be being able to tell the push buttons. And then channel 1 is the actual throttle. So we put it to channel 1, and then we move the throttle back and forth. It works. So all I'm going to do is I'm going to fold it up. I was debating on whether I should put a little bit of super glue in between. I think I'm not. I'm going to fold it up and see how the screws will, and put the screws together, and we'll see how it all gets put together. Okay, it's finished. Now the screws weren't long enough to actually work, to actually make penetration and hold it together. So what I decided to do was I decided to just take super glue and dump super glue down the seams. So that was like the rogue way of doing it, but I just wanted to go ahead and get this done. Like I said, if I actually knew what I was doing in Fusion 360, I probably could have made this much better, had a much better seam and what have you. But I want to press forward and keep on working on the project. But it pretty much works out great. It feels nice. The potentiometer feels nice. I tested it out after I put it together. It works. So if anything breaks, I'm probably gonna have to destroy the case and print a new one because I super glued it. I don't know if the super glue is gonna pop apart either. I assume that stuff kind of melts the plastic together. Now the one thing is these buttons on the bottom. So I went and I super glued little button heads on these buttons, and so far they're holding up good. The only thing about it is these buttons, I guess when I glued them in place on the inside, it messed up with the resistance of the buttons, so it doesn't make good contact. But these buttons won't be necessary, so if they don't work, it won't be that big of a problem. I'll just have the buttons on the actual control board on the skateboard. Oh yeah, and the USB worked out perfect. That's the perfect size hole and everything to charge it. And the lights lined up perfect for these holes here. So, like I said, it's not perfect, and I probably made it real complicated than what I needed to get what I needed. But it works, so I'll be moving on. And next part, we'll be putting together the stuff for the main control board. Thanks for watching.